Hi folks, Brian Benz here, Cloud Advocate at Microsoft, introducing you to another JDConf 2024 on-demand session. In this session, Mark Swatosh is going to introduce the latest developments in the Jakarta Concurrency project. It's a great way to scale your applications, and I'm sure by the end of the session, you'll concur. Take it away, Mark.
Hi, my name is Mark Swatosh, and I'm a committer on the Jakarta Concurrency project. Today I'm going to give you a quick update on what's new in the upcoming Jakarta Concurrency 3.1 release. To start us off, Concurrency 3.1 will support running on Java 17 and Java 21. As for new features, there are a few additional annotations, improved context support for flows, and support for one of the most anticipated Java features in recent memory, virtual threads. In alignment with the CDI specification, add-inject can now be used to obtain instances of managed executor service, managed scheduled executor service, and context service. There is also a new annotation, @schedule, which can be used with asynchronous methods to repeat the method on a schedule. To support contextual flows, context service has two new APIs, contextual subscriber and contextual processor. It's already possible to contextualize a flow using a managed executor, if the publisher allows providing an executor. In the case of a publisher which does not allow providing an executor, these new APIs can be used to provide context in the subscriber. Virtual threads are an exciting new addition in Java 21. With Concurrency 3.1, virtual threads can be enabled on a managed executor, managed scheduled executor, or managed thread factory definition by specifying virtual equals true. There are a few important things to note with virtual threads in Concurrency 3.1. They require both running on Java 21 and a Jakarta EE runtime which can provide virtual threads. If either of these conditions are not met, the executor will use platform threads instead. Now let's take a look at a demo of the new Concurrency 3.1 features running in a sample application on OpenLiberty. Let's take a look at our sample application running on Java 21 on OpenLiberty. The application has 3 REST endpoints, each of which exercises a new function of Jakarta Concurrency 3.1. If we take a look up here, we can see the @inject being used on a managed executor service and a context service. For the managed executor service, we are also using @with virtual threads, which is a CDI qualifier. And that'll make sure that we get this managed executor definition, which is using the new virtual equals true to provide virtual threads. If we take a look at our first endpoint, schedule, it calls into the concurrency beans counter method. This method is an asynchronous method that uses the new @schedule annotation with a cron string that causes it to run every 3 seconds. It just adds a count to a counter and returns that to the application. The second REST endpoint is contextual flow. This one uses MongoDB and the reactive streams driver to insert a document into a Mongo database. The insert1 method returns a producer, and this producer does not have any way to configure the executor being used. And so we can use the new contextual subscriber API method to contextualize the Mongo subscriber that we connect to the producer. So in the onNext method for the subscriber, we check to see if the document was inserted into the database, and then we go and we do a lookup in initial context in java::comp env. This will only succeed if we have access to application context. And then we return the looked up string to the application. Our third REST endpoint is virtual threads. For this endpoint, we spin up 100,000 virtual threads, each of which just does a simple sleep for 1 second because that's an easy blocking task. This is where virtual threads really excels, is when there's a lot of threads and simple blocking tasks. So if we take a look at the application, we can try out the schedule endpoint, and we'll see that the count begins and increments every 3 seconds. If we try the contextual flow endpoint, we get back our string that says hello from Java :comp env. The document was inserted successfully. And then if we try out the virtual threads endpoint, we can see that 100,000 threads were run in 1.88 seconds. I tried 100,000 threads with a platform threads and very quickly ran out of memory. Thank you for watching. I hope you enjoyed this update on Jakarta Concurrency. If you'd like to try the new features, check out the sample application on GitHub. If you have an idea for a feature you want to see in a future release, you can get involved by opening an issue in the Jakarta Concurrency GitHub repository.
Thanks for watching. Check out this and more at jdconf.com.